Hi, so I attended the lecture titled Einstein's Cosmos and Quantum by Dr. Abhay Ashtekar, and I found this lecture particularly interesting because it discussed the essentials of quantum physics, and that's something that I keep hearing about on TV and movies and in class, but most people don't really know anything about it. So this video will be on my take on the lecture and some things that I found especially important. So in 1915, Einstein discovered general relativity, and he published the gravitational field equations of general relativity, and we now call those equations the Einstein equations. And the idea is that the laws of physics are all the same for non-accelerating observers, and he showed that the speed of light within a vacuum is the same no matter what the speed of the observer is. As a result, he concluded that space and time are interwoven into a single continuum that we now call space-time. According to his theories, events that occur at a particular time for one observer could occur at a different time for another observer. And in 1930, a Belgian Catholic priest, astronomer, and a professor of physics named Georges Lemaitre proposed a dynamic model of the universe starting at the Big Bang. He theorized the expansion of the universe, something that's usually attributed, or actually misattributed, to Edwin Hubble. So initially, the Big Bang and cosmology were not really understood, but nuclear synthesis and cosmic microwave background helped explain the phenomena. Nuclear synthesis is a process that creates new atomic nuclei from pre-existing nucleons, specifically protons and neutrons. Cosmic microwave background, or CMB, allowed us to prove general relativity by comparing values from 380,000 years ago and 14 billion years ago. CMB is electromagnetic radiation left over from an early stage of the universe in Big Bang cosmology. Inflation is a phase of rapid expansion the universe underwent soon after the Big Bang, and quantum gravity was needed to explain inflation and quantum physics. Quantum gravity requires quantum geometry to verify Einstein's theory, and loop quantum gravity retains Einstein's fusion of gravity and geometry, but uses quantum geometry. This makes the fabric of space woven into a one-dimensional fabric. Now, to summarize, I found this lecture very interesting because, again, quantum physics is something that I hear about in chemistry and in physics and everything, but I don't really understand it. And I don't think most people really do understand it, so I found it really important to attend this lecture. General relativity is really beautiful. It accounts for many phenomena, but it remains incomplete. But the likes of Einstein helped explain it. Now, loop quantum gravity has turned the Big Bang into the big bounce, and quantum gravity fills many of the remaining voids in general relativity.